Okay, this tutorial I'm going to look a little bit more, go into a little bit more detail about chemical reactions and compare chemical and physical changes. So, if we just get that out of the way. Alright, so firstly, how do we know we've actually got a chemical reaction? When we mix two things, they don't necessarily always react. I can mix sugar and water. It's not actually a chemical reaction, we're just making a mixture. So the signs of a chemical reaction are these 5. We can get a change in colour, so you've probably mixed two things together in the lab and they've changed colour. A change in smell, that's actually how a lot of cleaning products work. They might combine or react with the smelly compound, the smelly substance, and when they combine with it they make a new substance that doesn't smell. So it's not that the smelly thing just disappears, it's actually been reacted with to make something different that doesn't smell. So number 3, if a gas is produced, so often if something fizzes, we get sort of bubbles often being released. If a gas is produced, that's a definite sign of a chemical reaction. Remember, in a chemical reaction, a new substance is produced, and if a gas is being produced, well, that's our new substance, or one of our new substances. So that's kind of a clear sign we've got a chemical reaction. Number 4, a precipitate, or a solid forms. So if we mix two liquids and a solid starts to form, we've probably got a chemical reaction. And that solid is probably, again, the new substance that's been formed. And the last one, if it produces heat or light, then it's probably a chemical reaction too. So those are 5 signs of a chemical reaction, 5 clues that you've probably got a reaction going on if you've combined two things, or if you're heating something and these things happen, you've probably got a chemical reaction. Alright. So, physical versus chemical change. So what is a physical change? Well, physical changes are things that are easily reversed, and they often just involve state changes. So if I melt ice into liquid water, or I freeze it, it's just a physical change. We haven't changed what it's made out of. In both cases it's still water, it's H2O. It doesn't actually change what material it is. We haven't made anything new. If I drop a glass and it smashes, it's pieces of glass, but it's still glass. It's still the same material. And these things are generally more easy to reverse. So if I melt ice into water, we can just freeze it back again and get it back into that solid ice. If I drop a glass and it smashes, well, in theory you could actually melt the glass and reshape it into its original form. We could even undo that one. So a chemical change is another term for a chemical reaction. So a chemical reaction is not easily reversed. It's very difficult to kind of undo something that's reacted. And you can imagine with our magnesium and our oxygen forming magnesium oxide, it would be very difficult to try and somehow split that magnesium oxide back into the metal, the magnesium that we started with, and the oxygen. So chemical reactions are often more of a sort of a done deal. They're more difficult to reverse. Then they always, now that's the key point, guys, they always result in a new substance being formed. So for instance, like with that last example, the magnesium oxide is the new substance. So it might be a compound that's being produced or formed. Okay, so I've got some questions here just to use as some examples. So for each of the following, decide whether they are a physical or a chemical change, and give your reasons. So A, a match burns. B, an ice cube melts. C, sugar dissolves in tea. D, a glass is broken. Well, I used that one as an example. And E, compost decomposes. So let's go through them. You might want to pause and you can try and answer it before I do. So A, a match burns. That's a chemical change. It's pretty hard to undo that one. And we definitely get some new substances being produced. The black sort of charcoal left at the end, as well as maybe some smoke. So we've definitely got some new substances being produced there too. B, an ice cube melts. It's just physical. In theory, we can put it back in the freezer and freeze it again. We can undo that pretty easily. And we haven't made a new substance. It's still just water, whether it's solid or liquid. It's just water, it's the same material. C, sugar dissolves in tea. Now this is a tricky one. Sugar dissolving in tea is actually just a physical change. The two have mixed together, but they haven't reacted. there will be no sign of a chemical reaction. There's no fizzing, there's no light produced. Alright, the sugar and water in the tea have just basically mixed together. And if we evaporated off all the water, the sugar would actually be left behind. So you can even kind of undo that one. D, a glass is broken. Well, I kind of gave that one away. That's just a physical change. Again, we haven't made a new material. We've just split it into smaller pieces. So that's just a physical change. E, compost decomposes. Another tricky one. So this is, guys, when bacteria and things break down the compost. And it is actually a chemical change. There's actually a whole bunch of reactions going there where some substances, some compounds are being split or broken down into smaller or simpler ones, maybe even being broken down into elements. And when they're broken down into those smaller things, we're making new substances, substances that weren't there before. And the compost heap, it's kind of, you can imagine that, when it starts, the materials, the substances you have there are very different from the materials you're left with, that more like that soupy, liquidy mixture of materials that you get at the end. So we've actually made some new substances. It's definitely a chemical change. Okay, so this next one here, which of these represents a physical and which a chemical change? Explain your answer. So A, is this the physical or the chemical? So let's look at A and B. A is the chemical change. And the reason for that, the reason you know that straight away, is we've got a totally new substance formed here. So we've got a new compound. Here we had two elements. So we've got a white element, even though they're in pairs, that's an element, only one type of atom, and a black element. Okay, now, and atoms aren't actually colored like that, but it's just for illustration. And when they combine like this, we've actually got a new substance, a compound being formed. So this could be magnesium and oxygen combining to form magnesium oxide. So that would be an example. Down the bottom here, well, it looks like basically here I've got a solid, something maybe like ice, melting into liquid water. It's still made out of the same materials. We haven't actually made a new substance. It looks like both of those are elements. Okay, on to the next bit. So, guys, here's some questions that are maybe a little bit more tricky. So label each box in the following diagram either element, compound, or mixture. So I've got 1, 2, or 3, and one we've got two lots up here. So let's look at those at the top here. This first box is an element. There's only one type of atom in there. This box here, we've got another element, only one type of atom. Number 2 is a mixture. Alright, so we've got two different elements floating around there. We've got a mixture, we've got different particles. And number 3 is a compound. So here we've got the particles, each part is the same, but they're made out of two or more different atoms. So 2, label the reactants and the products of this reaction. So number 1 are my reactants, and number 3 are my products. Number 3, what evidence is there that a chemical reaction has occurred in this series of pictures? Well, we started with these substances here, number 1, and we finished with this one here, number 3. We've made something new. A new substance is formed. So that's going to be without any of the signs of a chemical reaction. We don't know whether heat was given off or bubbled or anything like that. But here, guys, we can see a new substance has been formed. Do you think, question 4, do you think the product will have similar properties to the reactants? Explain your answer. No. It's a new substance. It will have its own, or it will have different properties from the elements from which it was formed. Extension. The reactants in this reaction are hydrogen and oxygen. Can you figure out what the product is? So let's start with, which one would be hydrogen and which one would be oxygen? Would the pink ones be hydrogen and the other one's oxygen? Or would it be the other way around? How can we figure that out? Well, the pink ones must be the hydrogen. If you look on your periodic table, you'll remember I told you that they're arranged in order of size. Hydrogen is the first atom, so it must be the smallest. Oxygen, I think, is comes a little bit further along. I think it's number 8. So oxygen is going to be significantly bigger than hydrogen. When they combine, we can see here we've got each molecule, each little group, each molecule is made out of 2 hydrogens and 1 oxygen. So H2O, this one's water. You probably know that formula. Cool. So that was a bit of an extension. We're going to cover formula in some of the other tutorials, but I thought I might throw that one in here. Cool, I hope that helped, and good luck for your tests.